Imagine waking up tomorrow, pulling back the curtains, and finding a second star burning right next to our sun. The very first thing you'd notice is the ground. Every tree, every person, and every car casts two distinct shadows, stretching out in a sharp V shape across the pavement. Looking up, the sky feels different. It is significantly brighter, but the light is piercing. It lacks the warmth of normal daylight, feeling unnatural and incredibly harsh on the eyes. Within hours, the internet explodes. Astronomers scramble their telescopes, aiming at the anomaly, and their data confirms the presence of a second massive star inside our solar system. The immediate terror comes from the physical reality of the situation. A massive celestial body has suddenly materialized within our immediate cosmic neighborhood. Under normal circumstances, the closest star to Earth is Proxima Centauri, over 4 light-years away. For a second sun to appear in our sky, something has crossed a distance of trillions of miles to enter our local space. Astrophysicists call this a rogue star, a stellar wanderer unbound by a galaxy. It has drifted directly toward our solar system. For billions of years, our planets existed in an isolated gravitational bubble. Now, this intruding star shatters that delicate balance. Identifying the object as a rogue star shifts the global response from curiosity to scientific panic. We are looking at a visitor that hasn't been seen in this system for eons, and the implications for our stability are unknown. Over the first few days, the physical changes on Earth build rapidly. The most obvious difference is the heat, as daytime temperatures spike drastically across every continent. The night fails to provide relief. With a second star in the sky, darkness may vanish entirely depending on its position. The atmosphere begins to relentlessly trap thermal energy without its natural cooling cycle. Injecting this much continuous heat into the atmosphere changes global weather patterns. The oceans warm rapidly, spawning massive, fast-moving superstorms that dwarf any recorded hurricane. While the rising temperatures and blinding light are the most immediate effects, a second, invisible force is simultaneously acting on the planet. Every star carries a massive gravitational footprint. As this second sun moves deeper into our system, its gravity begins to exert a physical pull on everything in our local space. A star is incredibly dense, meaning it exerts a colossal gravitational pull. Now, 2 different stars are pulling in conflicting directions on every planet, moon, and asteroid. This orbital map displays the breakdown. The stable circular orbit of the asteroid belt is stretched into chaotic ovals under the new gravity well. With their paths broken, millions of space rocks are redirected inward. Earth becomes a target in a cosmic shooting gallery. Over weeks and months, Earth's own path around the sun destabilizes. Our planet is caught in a tug-of-war between 2 competing gravity wells, elongating our once circular orbit. This creates chaotic seasons. We are dragged closer to the stars for periods of intense heat, only to be slingshotted out into the cold, triggering sudden deep freezes. Orbital mechanics break down, disrupting ocean currents and global agriculture. These shifts would lead to a collapse of the biosphere, long before the surface temperatures alone could finish the job. Eventually, the system reaches the stage of binary capture. The original sun and the rogue star lock into a gravitational dance, pulling at each other directly and deciding the fate of everything orbiting them. One outcome is the gravitational whip. The complex physics of 2 massive stars orbiting each other could rip Earth straight out of the habitable zone, ejecting us into the freezing void of deep space. Alternatively, Earth could be caught in the tidal drag of one of the stars. We would spiral inward, closing the distance until the crust melts and the atmosphere ignites. When 2 massive gravity wells fight for dominance, a small rocky planet trapped in the middle has no path to long-term stability. Returning to actual physics, space is vast. If a rogue star were heading our way, its approach would take thousands of years, giving us generations of warning. However, rogue stars do exist. They wander through the darkness of our galaxy right now. While a direct collision with our solar system is rare, it remains a physical possibility. If 2 suns appeared in the sky, it would mark the beginning of an unstoppable change to the solar system. The question for humanity would be how much time remains to witness it.